Okay, video 2. We just got through our first video of doing molarity using molar mass, using grams, finding grams. Like I said, there's going to be another practice problem on there for you to use. There's also going to be a full worksheet on you there for you to practice with it. It's not that big of a deal. It's almost exactly like what you did last week, just one additional step. That additional step is something we've been doing all year, so it should not be a problem for any of us. So, moving on, we have dilutions. Now, a dilution is basically lowering the concentration of a solution from what it was before. So if you have a solution that's more concentrated than you need to dilute the solution. Now, you're probably thinking, when's this ever going to be useful to me? Well, let me talk to you about it for a second. Well, it's useful to me because when I get chemicals shipped to the class, to the school whenever most of the chemicals that I have stored in the chem closet right now are solutions. They're already made up at 12 molar, 13 molar, something like that, molar solutions. And then I have to dilute them down to the properties that I want to. Now, many of you are thinking, I'm not going to be a chemistry teacher. I'm not going to be a chemist. This isn't going to be useful to me. It is, because this type of dilution, this type of knowing the terminology for this at least will help you when you are doing stuff, say, in a kitchen. I know many of you have worked in a kitchen before. Some of you aren't allowed in a kitchen, which, having seen your lab skills, might not be a bad idea. But for those of you who, plan on being cooking functioning adults, dilutions are going to be used in your kitchen more often than not. You're also going to use them when you're doing something like working on a pool, working in anything dealing with solutions, which more often than not is a lot of what you do. So, we're dealing with dilutions. So, to dilute a solution, all you got to do is add water. Now, that's not always true. Sometimes the solvent is something besides water, but for everything that we're dealing with this year, it's just going to be water because water is the universal solvent. Water is universal solvent, so we don't have to worry about really anything else. We just got to say, hey, it's dissolved in water, makes our life simple, don't have to worry about it from there. So, dilute solution, just add the water. So if you have 1 liter of a 2 molar solution and you add 1 liter of water, the result is that you have 2 liters of a 1 molar solution. Now, I can go through a very, very long process and tell you and show you using the equation that we have why that is. But the basics of it is that the amount of what's dissolved stays the same. We're not adding more in, we're just adding more solution, more possible solution for there to be. So in a 1 liter of a 2 molar solution, there's 2 moles present. When you add another liter, there's 2 liters, and then there's 2 moles. So you have 2 liters of a 1 molar solution, because 2 divided by 2 is 1. So what happened was scientists got smart. They're like, I'm not doing these equations more than once. That's too much work. So what did they do? They found that if you have the molarity of one solution along with its volume, and and either the molarity and volume of the solution that you need, you can solve for everything else. So to calculate the dilution, it's the following formula. M1V1 is equal to M2V2. So molarity times volume of one solution is equal to molarity times volume of the solution you're diluting. This is only true for diluting solutions. So if you're trying to compare two completely different solutions, it's not going to be the same. It's only dealing with dilution. So I take the concentration of one thing, of one, say, acid, 12 molar acid, and I need it to be 1 molar. I'm going to plug in the numbers for this dilution. Okay? I promise you it's not that bad. We'll take a look at it right now. So, we have our practice. We no longer need our periodic table, so this is going to be a little bit easier. So we have our equation M1 V1 is equal to M2 V2. So a 300 milliliter dilution of 1.89 molar HF. Stopping there, we're already told two different pieces of information. I know that we have a 300 milliliter solution, so I know that milliliter is volume. 300 milliliters. Dilution of 1.89 molar HF. Now, molarity is probably the easiest unit to find in any problem because it's going to already be marked as molarity. So we have molarity is equal to 1.89 molar HF. Now, these two numbers are connected because it's saying of 1.89. So I'm going to go ahead and mark both of these with 1. Is created from a stock solution of 12 molar. So we have a stock solution. If you don't know what a stock solution is, it's what the solutions that are in my stock room. If you haven't seen the stock room, or I should say the stock cabinet, it's the little acid-base thing that's in the room right between me and Miss Sudos. It's where I keep all the stock solutions that I get from chemical companies. They ship them to me and we get it sent out just fine. So, of a volume of a 12 molar 12 molar stock solution. And we're looking for volume of that solution. So, right now I'm looking for V2. So how am I going to get V2 by itself? Well, it's being multiplied by M2. So, how do I get rid of something that's being multiplied? Well, if it's being multiplied, the easiest way to get rid of it is to just divide it. So I'm just going to go ahead and divide both sides by M2. And then that gives me V2. That's it. So all I got to do is plug stuff into there. So M1, I said, was 1.89 molar times 300 milliliters. Now, units are very important here. If you notice, I don't actually have to convert my units to liters here. I don't. I can keep it as milliliters. The only thing is that I cannot give my reportings in liters. So what has to happen is that my volumes have to match. So if I have one in cubic centimeters, the other, and I'm not looking for the other one, then it also has to be in cubic centimeters. If the units cancel, then that's what the units have to cancel. That's basically what I'm trying to get at. So if I have milliliters and liters, one of them has to change. But if I have milliliters and I'm looking for milliliters, then nothing has to change. We just go ahead and go with everything that we have. It will all cancel out itself. So M1 1.89 times 300 milliliters divided by 12. So 1.89 times 300 divided by 12 gives me 47.25 milliliters of HF. So, how many milliliters of the stock solution do I need? 47.25 milliliters. Now, maybe you're asking, how many sig figs? Well, I'm going to go ahead and assume that there is a decimal point after that 300, because only one would not give me the accuracy that I would need. So I'm going to just go ahead and say 3, so 47.3 milliliters of HF stock solution. And that's all that there really is to it. It's not that bad. It's one simple equation, usually just one division to get what you want by itself. Plug everything in. The hardest part is just identifying which one is which. Just see what two numbers, because it's always going to be at least two numbers that are connected, meaning that it's saying 300 milliliters dilution of 1.87 molar HF. So because it's of that, these two numbers are connected. So they're going to be on the same side. Doesn't matter which side, just matters that it's a side. Okay? So that's all for this week. Make sure you take a picture of your notes and send them in. Please do try to put them uploaded. A quick reminder about grades. I try to put in grades on Monday, if not Tuesday, around Tuesday sometime during the day. I'm not going to grade throughout the week just because it's not due until Monday at noon. So please make sure that you are keeping track of that. I'll be doing my best to keep grades in. If you have any questions, as always, please make sure that you email me. I'm on my computer as often as I can be throughout the day. So, in the meantime, stay safe, stay inside. You got this. Have a good day, everybody.